Hi, I'm Renee, and the physics phenomenon I'll be discussing is circular motion. So, circular motion was what we were discussing in the morning. I took my headphones, I swung them around. Now, even though I was swinging them around in the circular motion, it had a lot more than actually seems to be a player. Say, for example, we have a circular path, a perfectly circular path, right? Let's draw it out on here. This circular path, drawing. It's a bit tough drawing it like this, right? But let's imagine that's a circular path, right? And let's imagine that it's the center of it, and there's an object like this moving along that circular path, right? It's moving like this along the circular path. I know it's quite hard to see, but I'm drawing arrows here, moving along the circular path, right? And let's say that it has a tangential velocity traveling tangent to the circle right there. It's traveling tangent to the circle and has an acceleration centripetal, a centripetal acceleration pulling towards the center. Now, why is acceleration important? This tangential velocity telling the cart, or this block, to fly off the circular path, fly off in this direction, right? Fly off here, right? This acceleration centripetal, the centripetal acceleration, is pulling it towards the center. In fact, when an object is moving with constant velocity in a straight line, there's no acceleration acting upon it. However, when it moves in a circle, there is acceleration acting upon it. Centripetal acceleration, making it change direction, making it go from going there to maybe a few seconds later down here with this velocity tangential. Remember, the same centripetal acceleration though, pulling it towards the center. So while the velocity does not change in magnitude, it changes direction and therefore acceleration is occurring. So we can say that the sum of the forces acting in this system does not equal zero. In fact, the one force that does act in the system is the centripetal force, which is composed of a mass times an acceleration. This mass being the mass of the block, right? And its acceleration being the acceleration centripetal. The mass of the block is pretty easy to calculate. We can put the block on a scale and find the mass, right? Acceleration centripetal, however, there's a specific formula we use to calculate this. Watch closely. Acceleration centripetal. That is equal to the tangential velocity squared divided by the radius of the circle, of the path it travels. So we'll measure our radius here, right? A radius of the circle, and we'll take the tangential velocity, we'll square it, we'll divide that by the radius here, and that's how we'll get the centripetal acceleration. With this mass and the centripetal acceleration, we can calculate the centripetal force. Let's talk about a real-world example of tangential velocity. Now, if you've ever seen NASCAR on TV, or any car race in general, any really race in general, you might notice the roads are shaped a bit like this. I have a photo on my computer. I don't know if you can see it properly, right? Notice how the road is sort of bent inwards, right? Now that inward bent road, while it does look cool and makes the races look a whole lot cooler, there's actually an important physics reason as to why the road is bent inwards like that. It's because these cars traveling very quickly, they have a high tangential velocity. And the centripetal force, the friction by itself, is not enough to keep these cars from flying off the track. So this track was designed with this in mind, and it's bent inwards because the force of gravity pulls the cars towards the center of the track, making them less likely to fly off. The gravity itself becomes a centripetal force acting upon these cars. This is really important because it's called the angle of banking. And if you've ever been on a ramp on a freeway, going to enter the freeway, there's a ramp that's circular, there'll be a recommended speed on it. That's because engineers like me, my major, they've calculated, all right, if a car is moving at this tangential velocity, right, will it fly off the track with this angle on it? So they've calculated the angle, they've calculated the velocity, they've given the recommended velocity so that if you travel at this velocity, you will not fly off the track. And I feel like that's really important because when we don't design this in mind, like a case happened in India,
a lot of bad things get said, like there was a ghost in the road that made the cars crash. In fact, that was actually the story of a road that I visited in India. Turns out there was no ghost. The angle of banking had been incorrectly calculated, and that's why the cars were crashing. When some engineers came and fixed the road, the crashes stopped. So I think it's really cool that we can use this physics concept of circular motion when we're designing roads and cars, and that can help us in the future.